Hi, this instructional video is about functions, completing the table of values for functions. And this instructional video is dedicated to one of my students who came up asking me for specifically an instructional video for this one. So, I love chocolate chip cookies. Let's start with something simple. Check this out. Here's a function, y is equal to 4x. Now this is called a function, whereas this is called an expression. An expression has a simple term or terms, but you don't really solve anything. You could simplify and you can evaluate. However, that's about all you can do with expressions. Now this is called a function. Functions you can solve. It has an input, and if there's an input, there must be an output. So if there's an input and an output, you could make a table of values. So you could solve functions, and you could also graph functions. And later on, there will be a more instructional video about graphing linear functions, such as this one. So expressions, you simplify or evaluate. Functions, you solve or graph. So obviously, this one is a function. So what do? Here's a table of values. Check this out. If I have a table of value in a vertical format like this, let's select some table of values. Let's select some inputs. For example, if I put a -2, that means let's put where the x is a -2. Then what would the y become? Well, to figure that out, you just simply go y is equal to 4 times x, but where the x should be is now the input of -2. So 4 times -2, well, you know a positive times a negative will come out to be a negative number. And 4 times 2 is 8. So the input is -2, then the output becomes -8. So if I set -1, then what would the y become? Well, to figure it out, you do the same thing. Y is equal to 4 times x. But where the x should have been, instead of -2, this time you're going to make it -1. Again, positive and negative becomes a negative. And 4 times 1 is 4. So there it is. Now, this is where I ask my high-speed kids to think about, look what's happening. When you go from -2 to 1, -1, on the x, then the y becomes -8 to -4. And some kids, they start to see a pattern. Hey, as the x becomes increased by 1, the y's are increasing by 4s. Does that mean if I let x equal 0, then if this is -8, this is -4, then this is also going to be 0? Let's check. Y is equal to 4 times 0 this time. Well, yeah, obviously, 4 times 0 is 0. There it is. And can we continuously predict that the next number will be this time +4 and +8? And that'll be a yes. So one of the things you should think about doing when you're completing the table of value is to recognize a pattern. And many times, if you recognize one pattern, the rest is the same thing over and over. Just be sure that the domain, or the input, yes, is consistent as well. So, since we started with y is equal to 4x, now let's make it a little spicy. What if I said this time, y is equal to 4x plus 3? Ooh, scary, huh? And why don't I use the same table of values, just like before, as -2, -1, 0, 1, and 2 as inputs. You try to figure out what the y should be. Try it. I feel like having chocolate chip cookies. So, yeah, it's the same thing as before. Y is equal to 4x. But this time you don't stop here. Whatever you get, you add 3 to that. So, if you started off with -2, the way you want to figure out what y is, to say y is equal to 4 times, instead of x, it's going to be -2. See, just like before. Except you don't stop there. Whatever you get, you're going to add 3 to that now. So 4 times -2, again, positive and negative, when you multiply or divide, it becomes a negative. And 4 times 2 is 8. Now, things get a little tricky. This is where you simply go, look, you owe the bank $8. You have a negative balance. You borrowed too much money before. And now you're going to put in $3. You deposit $3. You're going to still owe the bank some money. Not as much as before, but you're going to owe them instead $5. Can you see that? So if the input is negative 2, unlike last time of being a negative 8, this time it's going to be negative 5 because we added 3 more to it. Now check this out. Now what's going to happen if I put in x equals negative 1? So you go 4 times x, which is negative 1 this time, and whatever you get, unlike last time where you stop, you're going to add 3 to that. Does that mean whatever you had was negative 4, so when you add 3, it becomes plus 1 or negative 1? Let's check. 4 times negative 1 is negative 4. Remember? Positive and negative, when you multiply, is a negative. Now here it says you owe the bank $4, and you put in $3. You don't owe as much as before, but you still owe them $1 more, a negative 1. So yeah. And now can you see the pattern here? Look what's happening. Last time it was negative 5, then it becomes negative 1. So if you were thinking about a number line, this was negative 5, 4, 3, 2, 1. That's 4 units away. So if you go 1, 2, 3, 4, where will you be? 0, 1, 2, 3. It's positive 3. And if you go 4 more units from there to the right, what would that be? 7. What would the next one be? Yeah, 11. That's how you recognize the pattern. As long as you get 2, as long as the domain, the input's the same, the outputs will be consistent as well.